name's Cassie Land, and my group's going to be doing frictional force. Frictional force is something that we experience every single day. This experiment will help teach the concepts of friction, make it easier for you to understand. Friction is a force that reduces the motion between two objects that are in contact with each other. It stops or slows down the movement depending on the friction of it. So for instance, a smoother object is going to have less friction because it doesn't have as much rubbing together. The rougher the surface, the more friction because it's going to have stuff holding it back.
How you doing? Today we are in the lab and we are going to do a lab on frictional force. Hi, my name is Zachary Mohamedou.
Kelsey Taylor.
Khalil Wilson.
And we are going to do a frictional force lab. So would you mind telling me, what is a frictional force?
I think he is. I hope so. I hope so.
Frictional force is
If he doesn't, I'm
rubbing your
gonna
hands together, I think.
I can't remember.
Yeah,
everything.
frictional force is, it's cold in this room, so I'm kind of cool. So if I'm moving myself or rubbing my hands together, I'm creating friction to create heat. So that's what I think it is.
What do you think frictional force is?
I think as you're walking, every step you take with your feet between the ground and your sole is friction and it helps you move forward.
Alright, in this experiment today, we'll be figuring out the frictional force between this block and the level surface. So, in this project today, we will be figuring out the frictional force between this block here and
This plank of wood.
this plank of wood.
So we need to figure out what's the mass of that.
First of all, right now this mass is unknown. So what we got to do? Weigh it. Well, well, we can use. If this is like the olden days, we would use like a scale like this. You'd have to, tittle fiddle with it, But you high tech.
Let's do some high tech.
High tech. You feel me? So let's see how much this weighs. We got a little digital weighing scale here.
Make sure you put it in the units.
Yep. This is in grams, by the way. This is approximately 188.9 grams. So I'm just gonna approximate that and call that 189.
Alright, so now we gotta get our weights.
Depending on what's going on in the experiment, there are different components that are required in order to cause friction, such as there is already a natural friction between the block and the plank, yeah. So in this experiment, we're going to be adding different weights in different increments to see the type of relationship that the friction has with the weight.
Another component of this project is called the weight hanger. We'll be adding weight to this weight hanger to enable the block to move.
I know we're high tech, so let's see how much this weight hanger weighs. Okay, this is 50 grams for the weight hanger,
Which is the constant.
constant. Let's see if it moves with just the weight.
You think so?
It might. Hey, let's go. It is not. So let's add. Let's add a little bit because it has to be moving. It's 20. It says.
Oh,
We got a little movement going on. But I think we need a little bit more just to be on the safe side. So let's add 20.
we're gonna add 20.
20 grams.
Let's see.
Look at that movement. So we're looking for increasing an increment of 10 down
Our
here
constant of 50.
with our constant of 50. And then at the top, we'll be increasing an increment of 20 to see, movement.
So let's see what we're gonna do. So we're gonna put on the block right here.
This will be 50.
Alright. Let's see what we're gonna get.
50.
Done.
No movement.
Alright.
Hey.
Let's try the constant.
Increments of 10. Here we go. So the 50 grams added on top with the 10 grams added to the 50 on the bottom made movement.
Well,
All right. So to have a controlled experiment, this block needs to be at the same place every time. So would you mind measuring that for us?
let's get it right
It's about 40, right?
Yeah.
All right. So 40,
40
is that
centimeters?
centimeters?
Yeah.
40 centimeters every time has to, this was
Every
where that has to be.
We're gonna do it with 250, so 100.
100.
So, what do you think it's gonna take for it to move?
I don't know. Let's just go in increments of 20 again.
Let's see.
What you think?
About 60. I think.
60?
I say
60 together?
Yeah.
I'm thinking maybe.
Cause it was moving pretty fast, huh? Don't you think?
So I'm gonna go with about 70. I'm gonna go with 70.
All right. So let's see what this is.
All right, don't forget we got.
Don't forget.
Position.
You gotta position it. What position
Right
is it gonna
there.
be?
We got the mark.
Wait, let's.
40.
Want to measure it?
Yeah.
Measure again. Make sure it's 40. Ba-da-da.
All right.
All right.
All right, let's do it.
You ready? Put them weight on.
So we're at 70 right now. Let's try.
You ready?
Yep.
Ooh.
Okay.
It moved off the bat.
That was 70.
That was
Yeah,
70.
70.
Okay.
So we're gonna do another 50.
We can add another increment of 50 on here then.
Position.
Position.
Take it off. Got it right. Don't forget.
And measure it.
Yeah. All right.
You ready?
Ready. Set. Slowly but surely.
It's actually moving, y'all. Can y'all see that? You might want to zoom into this. Is some high quality action here.
So basically, it's taking 150. It's taking 70 grams to move 150
And
Correct.
all of this is causing what?
Friction.
So, for the conclusion today,
Friction can be found everywhere. Everyday life,
everyday life, everyday things,
classroom.
even in the classroom, you know. But in this situation, we're trying to find the frictional force with like via kinetic and static. The kinetic friction for this actually occurred faster with less weight than we thought. Our hypothesis was that it was gonna need more weight to move it, but I feel but the gravity along with the weight had our hypothesis wrong, proven wrong. So it actually takes less due to those components, and the more movement, the more friction, which means the more force.
Yeah. So, quick with the. I don't know.
So yeah,
Okay.
so yeah.
Wait, are you saying that friction, the more friction it is, the more movement, or?
I think that's
Actually,
what you said.
not. I said that. I did say
Yeah,
that.
you did.
No,
So what is
that's wrong. Actually, the more movement, the less friction. Because friction is what slows it down.
Yeah.
So, yeah. Everybody makes mistakes. Everybody has those things.